Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we'll be looking at GCSE Physics Specific Heat Capacity. So today we'll be looking at different substances and how easy it is to heat them up and how easy it is to cool them down and why. So, this is essentially what specific heat capacity is. So without further ado, let's get started. Now, first of all, let's notice this, that in order to heat up 1 kilogram of water by 1 degree Celsius, we require 4,200 joules of energy. Now, to heat up 1 kilogram of mercury by 1 degree Celsius, we only require 139 joules. So, that essentially demonstrates that different objects have different heat capacities. And this is important because in industry often we want to calculate how much energy we need to heat certain substances up, certain oils, even in research sometimes. So this of course has plenty of implications, and this bit here, that demonstrates what specific heat capacity is. Specific heat capacity is right here, the definition of it. Specific heat capacity is the energy needed to raise the temperature of 1 kilogram of substance by 1 degree Celsius. That's the definition. So from this we can say that water has much higher specific heat capacity than mercury. And that means also by extension, it means water stores much more energy than mercury does. So now why do we have all these different substances having different heat capacities? Why is it so much harder to heat up water than it is to heat up mercury when we're talking about the mass? Well, one reason here is to do with internal energy. Every object, every substance has something called internal energy, and that is the energy contained by those particles that make up the substance. So that internal energy essentially splits into two different energy types. It splits into kinetic energy because particles are moving around and constantly bumping into each other, constantly moving around, and that's movement, that's kinetic energy. But also particles have the potential energy stored within them that they can release under certain conditions. So this is one of the reasons why we have different heating capacities, because we have a different breakdown of how this, when we heat something up, we have a different breakdown of how that energy is spent, how much of it goes to kinetic energy, which is what temperature essentially signifies. Temperature signifies the amount of kinetic energy particles have, the amount of movement the particles have, and how much of that energy will go into potential energy. So that debatably, that is one of the possible reasons why different objects have different heat capacities. Now, another important reason, guys, is that definition of specific heat capacity is based on the mass of the object. So we are only looking at mass. We are only looking at the difference between heating up 1 kilogram of water, how much energy we spend to heat up 1 kilogram of water, and we are looking at how much energy we spend to heat up 1 kilogram of mercury. So essentially, we're just looking at masses. We are dealing in masses. Now, that actually is the way to do specific heat capacity, but what we need to be thinking about is particles. So, if we think about it, mercury particles have much higher molar masses when you look at the chemistry. The chemistry of the molecule, they have much higher molar masses. So within 1 kilogram of mercury, we will have much less particles, much less mercury atoms, much less mercury atoms, then we will, in 1 kilogram of water, we will have much more water atoms because the molar mass of water is lower, so we can cram in more water molecules into that 1 kilogram, whereas in mercury we can do much less. So one of the explanations here is that we simply need to heat up more water. We need to heat up more particles of water than we need to heat up mercury. And that's another possible explanation for that difference in specific heat capacities. So, how do we calculate this? How do we calculate specific heat capacities? How do we calculate energy changes based on the specific heat capacities of substances and molecules? Well, the answer is here, this equation right here. So, the equation goes like this. First of all, the change in thermal energy is equal to mass multiplied by specific heat capacity multiplied by the change in temperature. So that kind of makes sense, because based on the mass of the object that we're heating up, based on how much we heated it up, and based on the specific heat capacity, we can determine how much overall energy we needed to put in or take out. So, of course, we can rearrange this equation as we would with most physics equations to find any one particular value. For example, if you want to find specific heat capacity, then you'll be dividing by temperature and mass. You'll be dividing the energy by temperature and mass. So you can rearrange this equation the way to suit whatever your question is, whatever you're trying to find out. So this is it for the heating capacities today, guys. Thank you very much for watching my video. I really like doing these videos for you guys to watch, and I really hope this video has helped you. If you think this video helped you, give me a thumbs up. Next time we will be doing physics. We'll be looking more into these internal energies of particles. So you can hang around for that and make sure you watch that video, because I will be expanding on that a lot, because I believe this is one topic that actually needs to be expanded quite a bit more than here. I just covered it very briefly. If you want to stay up to date on physics, maths, and biology and chemistry videos, and some biomedical science videos, make sure you subscribe below. Don't be shy, guys. And thank you again for watching. See you next time.